Welcome to section 6.1 for loops. This lesson is all about repetition, the good kind. By the end of this, you will know how to create and use for loops, understand how variables behave inside them, and avoid those sneaky infinite loops that can crash your program. Here is a game plan. Understand the structure of a for loop. Write and tweak your own loops. Get clear on scope, where variables live and die. Practice debugging and spot the signs of an infinite loop. Let's start with a cool scenario. Imagine you're launching a rocket to Saturn's rings. You'll need a countdown, but how could you write a program that counts down from 10 to 0? If you do it the long way, it takes 10 lines of system.out.println just to count from 10 to 1, and that's before even saying blast off. It works, but it's not exactly scalable. Now imagine counting down from 100 or 1000. That's not only painful to write, it's a nightmare to update. What we need is a smarter, repeatable way to handle this. Here's a peek at what it would look like to count from 100. It's basically the same line of code repeated forever. It screams, please automate me. You might think, what if I just use a variable like int I equals 10, then system.out.println I, then I minus minus. That does help a little, but still doesn't fix the repetition. We're still copying and pasting the same lines. Okay, let's think bigger. What if we could tell the program, repeat this block of code until we are done? That's what loops are for. We want to loop from 7 to 10 again and again, but with updated values each time. Java gives us three kinds of loops. For loops, while loops, and do-while loops. This lesson focuses on the for loop, the one that runs a specific number of times, which makes it perfect for countdowns. A common requirement in a program is to repeat the number of statements. Typically, the code continues to repeat the statements until something changes. Then the code breaks out of the loop and continues with the next statement. The pseudocode example shows the while loop that loops until the are we there yet Boolean is true. In programming, there are times when you want to work with multiple inputs, but you want to execute the same logic for each input item. Loops start at the beginning of a piece of code, execute the logic, and then return to the beginning of the loop with new inputs, ready to execute the code again. Let's go back to our countdown. We know when the loop starts, int I is 10. How long to keep going? I, as long as it's greater than or equal to 0. What to change each time? I minus minus. That's your loop structure. A for loop has three parts in its header. Initialization, it's done once at the start. Condition, checked every time before looping. Update, done after every loop cycle. All three are separated by semicolons. The body of the loop goes in curly braces. The initialization sets the loop counter. In this example, it starts at 10, prints each number, then says blast off when it's done. The condition decides whether to keep going. The condition is a Boolean expression like I greater or equal to 0. If it's true, the loop runs. If it is false, it exists. The update adjusts the counter each time. The update part changes the counter, usually with I++ or I minus minus. Without this, you risk getting stuck in an infinite loop. Time to test it out. In exercise 1, you'll open countdown.java, set a breakpoint, and step through the loop. Watch how I changes and how the loop executes one line at a time. In part 2, try changing the loop. Count up from 0 to 5, then try printing all even numbers from 0 to 20. You'll see how just tweaking the loop header changes the behavior entirely. You might wonder, do I have to write the update inside the loop header? Technically, no. You can't do this as in the slide, but it's not recommended. It's less readable and easier to mess up. In fact, all three parts of the loop header are optional, but omitting them comes with risks. No condition, that means infinite loop. No update, you'll never reach the end. No initialization, you hope that variable exists somewhere. Check this out. This loop runs forever. It has no condition to stop it, so it just keeps going. So be careful with this. In exercise 2, you look at infinite loop.java. First run it to see the problem, then modify it so it prints hello exactly 5 times and then stops. Infinite loops are great practice for debugging. Let's talk about multiple statements inside a loop. If you want more than one line to run, you need to use curly braces. Otherwise, only the first line runs. Without loops, repetition looks like the first example. But with a for loop, your code is way shorter, easier to read, and scalable. The variable I is what we call the loop counter. You can use it in print statements like math or logic checks. It's super useful for tracking where you are in a loop. Here is a heads up on scope. The loop counter I only exists inside the loop. Once the loop ends, I disappears. That's called its scope. Check out this code. You'll get a compiler error on that last line. I no longer exists. Here is another example. Inside a for loop, you can declare other variables too, like int k equals 3, but they also only exist within the loop block. Variables live and die within their own scopes. Now let's apply for loops in real scenario. Say you want to add 4 numbers together. You could write int n1 equals in.nextInt. Int n2 equals in.nextInt. But that gets messy fast, especially if you need to add 100 numbers. And yeah, if you have 100 variables, int n1, int n2, until int n100. There's a better way. This is smarter solution. This loop reads 100 numbers and adds them up all just with few lines. Much cleaner. Here's how scope plays out in this program. I and value exist only inside the loop. Total and n exist outside the loop and persist afterward. That separation keeps your code neat and prevents bugs. In exercise 3, you'll fix scope test.java. Your goal is to get 4 correct output lines. A count down by halves, count up from 0 to 5, count down from 5 to 10, multiply by 2 from 2 to 64. You'll be applying all your new loop knowledge here. Just a heads up, don't declare the same variable name twice in the same scope. If I already exists, you'll get a compiler error when you try to create another I. Rename one of them to keep your code clean. Variables like j can exist in different loops as long as their scopes don't overlap. But don't try to use j from the first loop inside the third. It's out of scope and will throw an error. One last point. You can skip the initialization in the loop header, but that keeps I alive outside the loop, which might not be what you want. It is safer to keep your loop variables inside the loop when possible. To wrap things up, you've now got a solid understanding of for loops. You know how scope works. You can debug infinite loops. And you have seen how powerful repetition can be in making your code efficient and clean.